one of the problems that you were working on involved the union of sets. Now, I emphasized in class, some people felt like I'd sprung the word union on them. They didn't know what it meant. Well, the definition of the word union is right there in the statement of the problem. It says everything that's in this set is in the union, everything that's in this set is in the union. So it's every element that's in this set plus every element that's in this set. So what elements go in the set? A and D, certainly, because they're in the set A. F, it's in both sets, but that doesn't change the fact that it's in one set. And also E, so I tried to put them in alphabetical order, but I had to squeeze that one in. But then if we go in alphabetical order, A, B, C, D, E, F, G, so we've got all of the letters from A to G that occur in one set or the other. And alphabetically, the next letter that we see is K. That's in set A, so it's here. And then we have W. Okay, it's in both sets, so it's certainly in the union. And Y and Z. So now we can double check. First of all, is every element of A here? Well, there's A, there's D, there's F, there's K, and there's W. Is every element of B in the set? Well, yeah, there's E, kind of squeezed in, but there it is. And there's F, and there's G, and there's W, and there's Y, and there's Z. Is there anything in this set that doesn't occur in one of these? If we want to really check this, is A in at least one of the sets? Yeah, there it is. How about D? Yeah, there it is. How about E? Well, there it is. F, there it is. G is there. K is here. W is here. It's also here, but Y is here, and Z is here. So everything in this set is in one of these sets, and everything in either of these sets is in this set. So this is the union. Now, the intersection is more restrictive. The intersection consists of everything that's in both sets. Has to be in both sets to be in the intersection. So here's the intersection of the two sets. Is A in the intersection? Well, it's here, but it's not here. Forget it. D? Well, D doesn't appear over here either, so it's not in the intersection. What about F? Ah, there it is. So it's in the intersection. K? No, don't see it over here. W? Yep, there it is. Okay? So W's in the intersection, and that's it. And I don't have to go through the elements of this set to see if they match this, because I've gone through the elements of this set to see if they match this one. And if it matches, we already found it, so we don't have to check Y and Z because it didn't appear here. We never had to look at it. Okay, that's the intersection of the two sets. Another question is of the complement of two sets. Okay, so complement is something that was introduced in the section that was due prior to this class. But A union B with an apostrophe, the apostrophe means complement, and it means everything that's in the universal set that's not in the set A union B. Okay, so of the letters that have occurred here, which ones don't occur in the set A union B? And I somewhere thought that I'd listed a universal set. I need to come back to that because I don't know where I listed my universal set. It's actually there in the statement of the problem. Okay, I didn't write it down here, but the universal set was the set A, D, E, F, G, K, W, X, Y, Z. X was in the universal set. It's not in the set A union B. So that the complement of the set A union B is everything that's in that given universal set that doesn't occur in A union B. So, and I wrote this out badly. Actually, yeah, I'm going to come back to this complement and do just a little bit more, just so you see everything on the board.